And now we start theme number 6, technical and economic characteristics of the technological process, technological documentation. Purpose of our lecture is learn to determine the absolute and relative indicators of the technological process, calculate the cost of the technological process, characterize the main types of technological documents. Plan of our lecture 6.1 Absolute and relative process characteristics, 6.2 Methodology of calculating the cost of the technological process, Basic technological documents, it's 6.3 Typification of technological processes, 6.4 Specifics of building group technological processes, 6.5 Design of technological processes on a computer. Write down to your notes our theme and our plan. And we start item 6.1, absolute and relative indicators of the technological processes. Absolute indicators of the technological process. The efficiency of the technological process is evaluated using technical and economic indicators. The following are used as absolute indicators. The complexity of the process. Use formula number 1. In this formula, TH is the piece time spent on the performance of all operations for manufacturing the part. N, small n, is the number of operations in the process. T, small t, pieces, piece time for each operation. If it is necessary to change the equipment, the time spent on the changeover should be taken into account. In this case, the piece calculation time is calculated according to the formula 2, where t small t is piece calculation time for each operation. The cost of manufacturing a part consisting of the cost M for the material, the basis wage P of production workers, and the sum of all other shop costs, Z, is equal to M plus P plus Z. It's formula number 3. The cost of processing the part is determined without taking into account the cost of the material, P plus Z. It's formula 4. Relative characteristics of the technological process. The relative indicators of the process are as follows. The coefficient of mean time equal to the ratio of mean time to artificial costing depending on the type of production. We use formula 5. This coefficient characterized the loss of time for work, that is not included in the main time. It's time for installing and removing the workpiece, etc. And thus characterizes the degree of automation of the processing process, the efficiency of equipment use. In serial production, the coefficient nu must be at least 0.65. Material utilization rate. It's formula 6, where small m is the mass of the finished part. G is the mass of the initial workpiece. In mass production, this coefficient reach a value of 0.85, in serial production 0.7, and in a single one its value decreases to 0.6. The load factor of the equipment being the ratio, the estimated number of machines up to the accepted number m suffix pr. We use formula 7. The coefficient nu can be calculated for a single operation or for all operations of a given process. In the latter case, this coefficient is determined by the formula 8. For serial production, the value nu is approximately 0.85. For mass production, not less than 0.8. The decrease in the value of this coefficient for mass production is due to the fact that it is impossible to load machines with other parts on the mass production line, as in mass production. Relative characteristics have no independent meaning and are in additional to absolute characteristics. Item 6.2. Methodology for calculating the cost of the technological process. Consider the method of calculating the cost. The cost of material, requisites for the manufacture of parts is determined by the formula 9, where C suffix m is the cost of 1 kilogram of material. T is the mass, m is the mass of consumable material per part. C suffix 0, the price of 1 kilogram of waste salt. And m suffix 0 is the mass of wage in kilograms. The basic salary of a worker for performing one operational is determined by the formula 10. So, the basic salary of a worker for performing one operational, P suffix OP, is determined by the formula 10. In this formula, R is the hourly wage rate of a production worker in гривнас. T штучная is the norm of artificial time in minutes. The basic salary of production workers when processing a part is equal to the sum of payments for individual operations, like in Formula 11. Workshop expenses Z, called overheads, with approximate calculations are taken as a percentage of the sum of the basic wages of production workers. For example, for serial production of general mechanical engineering, overhead costs are 200 to 250%. When comparing technical and economic options for technological processes, for a more accurate calculation of the cost price, the following elements of overhead costs are distinguished. The cost of depreciation of equipment, A suffix OB. The annual cost of minor repairs and maintenance of equipment, L. The cost of operating and depreciation of fixtures. The cost of cutting tools, E, big I. Payment for power, electricity, E. Additional payments, D. It's additional wages and social insurance deductions. When comparing variants of technological processes, the method of localization of shop costs is used, and the so-called technological cost is determined, which is understood as the sum of production costs for those items for which these costs are different for comparable options. Thus, the technological cost of manufacturing the part will be, according to the first options, we use Formula 12, and according to the second options, we use Formula 13. Where M are material costs determined by Formula 9. P, the wages of the main productions workers is determined by the Formula 11. Z, the sum of the elements of overhead costs that are different for the compared options. The component costs of Z are determined by the Formula 14. In this Formula 14, other components of workshop costs, which practically depend little on the type of machine used, as the processing method, are taking the sum when comparing processes options and are not taken into account. These include the cost of wages for support workers, administrative and technical and accounting personnel, the cost of heating, lighting, etc. The annual machine depreciation deduction per operation are taken in proportion to the time spent on the operation. we use formula 15. In this formula, small a is the number of percent of the book value of the machine deducted for depreciation. C, big C, the balance price of the machine in hryvnias. T, small t, piece time for the operation. Big F, real annual fund of machine time when working in one shift hour. S is the number of work shifts per day, and new machine load factor in time. Annual costs for minor repairs and maintenance of equipment per one operation are also calculated in proportion to the rate of unit time. Formula 16. Where beta is the number of annual percentage of the book value of the machine for minor repairs and maintenance. B is equal from 4.5 to 5%. The costs associated with the use of special device are determined by the formula 17. In this formula, big C is the cost of the device. Big N, annual production of parts. Small I, the number of years of use of the device. I is equal from, can be equal from 2 to 5 years. Q is the percentage of the cost of repairing the device, from 10 to 20%. The cost of cutting tools is determined by the formula 18. In this formula, big C is the cost of the instrument used in this operation. Big K, the number of regrins of the cutting tool until it is completely worn out, accepted according to the standards. Big P, the cost of regrinding the tool. Lambda, the number of percent of the basic wages of workers sharpeners. T, tool life in minutes. The cost of paying for power electricity is determined by the formula 19. In formula 19, big C is the price of 1 kilowatt of electricity in hryvnias. W is the need for electricity for this operation in kilowatt. Big N, it's electric motor power. New suffix M is the load factor of the electric motor in terms of power, depends on the cutting mode and is from 0.5 to 0.9. T, the main time for the operation in minutes. Small t, suffix 0. New suffix C, coefficient taking into account losses in the network. New suffix D is the efficiency of the electric motor. Additional salary, big D, when performing a separate operation is calculated by the formula 20. In this formula, small p is the number of percent additional payments from the basic salary, from 10 to 15%. Tau is the number of percentage social insurance contributions from the amount of basic wages and additional payments, average 7.5%. Additional wages D when processing a part is determined by the formula 21. The calculation of the cost price given above by the method of direct costing is laborious. In order to reduce labor-intensive calculations in the practice of designing operations, the standard method of calculating the cost is used. Its essence lies in the fact that the enterprise develops standards for all items of direct production costs reduced to 1 minute of machine operation. Using these standards, the costs for each cost element are determined. They are summed up and the resulting amount is multiplied by the unit time of the projected operation. The choice of the optimal variant by comparing the cost of production in some cases may be insufficient, since it is also necessary to take into account the payback period of investment according to the accepted variant. The payback period is determined by the formula 22, where K suffix 1 and K suffix 2 are capital investments for the first and second options. C suffix 1 and C suffix 2 costs of annual output for the first and second options. The payback period for mechanical engineering should not exceed 5 years. And now we start item 6.3. Basic technological documents, typification of technological processes. Write down to your notes this item. The main technological documents, like in this 3.1102, 2014, Unified System of Technological Documentation, Stages of Development and Types of Documents, General Provisions, are as follows. First document, it's road card. A description of the technological process of manufacturing or repairing a product, including control and movement, for all operations for various types in a technological sequence indicating the relevant data on equipment, tooling, materials. The content of operations is presented without specifying transitions and processing modes. Road cards are used for production planning. Next type of technological documents is operational card. Operational card, a description of the technological operation, indicating the transitions, processing modes, and estimated time standards. A set of operating cards is supplemented with a road card. Operating cards are used in serial and mass production. Next type of technological documents, it's technological process card. A description of the technological process for manufacturing or repair of a product for all operations of a separate type of work performed in one workshop in a technological sequence, indicating data on technological equipment. Sketch card. Sketches, diagrams, and tables necessary to perform a technological process, operation or transition in the manufacture or repair of a product, including control and movement. It's all basic technological documents. Next types of basic technological documents is technological instruction. Technological instruction. A description of specific methods of work when performing technological operations, including control operations, rules for the operation of technological equipment, a description of the physical and chemical phenomena that occur during individual operations of the technological process. Equipment list. Next type of technological documents. A list of used devices and tools, cutting, measuring, and auxiliary, necessary to perform a given technological process or operation. The tooling list or equipment list is the main document for calculating the plant's tooling facilities. Next type of documents is material list. Materials list. Data on workpieces and material consumption rates. Technological documentation is, in addition to various cards and lists, also includes drawings of output workpieces, a drawing of fixtures or interchangeable settings for them, a drawing of a special cutting, auxiliary, and measuring tools, etc. Operational control charts are developed for technical control processes in which control tools and controlled size are given, and a summary list of control operation is completed. Compiled. The composition and completeness of the technological documents necessary for the manufacture or repair of the products is determined by the list of technological documents. This list contains a list of all technological documents. Typification of technological processes. Work on the design and development of technological processes can be significantly accelerated and improved by using standard technological processes. A typical technological processes is characterized by the unity of the content and sequence of operations and transitions for a group of parts with common design features. Typifications of technological processes is such a direction in the study and construction of technology which consists in the classification of technological actions of machine parts and their parts, and then in a comprehensive solution of all problems that arise in the implementation of the actions of each classification group. When typing is carried out, first of all, machine parts are divided into classes according to the generality of technological problems solved in their manufacture. The most common division of parts into the following. First group, shafts, including axes, rods, pins. Bushing, including sleeves, liners. Discs, in particular rings, flywheels, pulleys. Eccentric parts, including crankshafts, crosses, levers, including connecting rods, earrings. Then planar details, including plates, frames, beds, tables, planks. Gear wheels, worm gears, and stands, etc. Each class of parts is divided into groups and types, taking into account their configuration and dimensions, manufacturing, quality requirements, materials used, and head treatment. When dividing parts of a certain class into types, parts are combined into one type in the manufacture of which the same rod for performing operations, the same type of equipment, the technological equipment are used. The second stage of typification is the development of a standard technology. If the parts are very similar in terms of design and technological features, then a single technological process can be designed for them up to the indication of time standards. If the degree of unification of parts is less than a technological process with less detail is developed for such parts. Such a process is used in the design of work processes something wrong with connection, but we are reconnected. For a group of parts that differ significantly from each other is designed but belong to the same class, technological instructions are developed. In the process of designing a typical technology, the problem of creating a typical, easily reconfigurable tooling is solved. When typing, the standard size of parts are unified and their number is reduced, which makes it possible to enlarge the size of manufactured batches of parts and apply methods of large-scale production with a higher level of mechanization and automation of operations. Thus, standard technological processes contribute to the introduction of the most progressive technological processes into production. The use of generic processes simplifies the development of processes for a specific part and reduces the time required for this, as well as speeds up the preparation of production through the use of normalized, easily changeable machine fixtures. And item 6.4, the specifics of building group technological processes. When considering the types of production, it was noted that the current mass production has significant advantage over serial non-current production. The desire to increase the productivity and efficiency of processing in conditions of mass production lead to creation of a method of group technological processes. This method is based on the classification of parts with the allocation into groups of such parts, the manufacture of which is characterized by the commonality of the equipment used, the same technological equipment, and the general setting of the machine. For each such group of parts, a so-called complex part is developed that contains all the elementary surfaces characteristics of the parts of this group. For a complex part, a technological process and tool setting are designed, which will be useful for any part of this group. As an example, explaining the role of complex part, like in figure 1, it's schemes of complex parts. Based on the complex part, the type of equipment, the design of the fixture, and the necessary instrumental settings are determined. The method of group technological processes is directly related to the unification of machine designs and their elements and is based on the unification of technological equipment, limiting its design varieties, sizes, and components. Computers play an important role in the development of group technological processes and the design of unified tooling. The key to the idea of a single setup for a group of parts is to drastically reduce setup time. The use of group technological processes is most appropriate on machines designed for multi-transition operations. Equipment for processing parts of a certain group is located in the sequence of manufacturing a complex part that is along the flow. Parts are manufactured in batches. Thus, the batch processing line is a sliding line in which each batch of parts can be processed according to the principle of continuous production if only the synchronization of operations is observed. The group technology method allows reducing the preparatory and final time from 40 to 60% and increasing productivity by 20 or 50% due to the use of group fixtures and debugging, targeted equipment upgrades, and the introduction of group variable flow lines. Comparing the methods of groups technology with the typification of processes, it can be noted that group technology is aimed at developing an operation, while typical technology is aimed at developing a process. This difference imposes features on the classification of parts in the methods under consideration. And 6.5, it's the last our item, design of technological processes on a computer. Conventional processes design methods are time-consuming. The limiting time for the development of processes, especially in the condition of serial and small-scale production, leads to the need to develop the technology on an enlarged basis without sufficient objective justification of the accepted option. In order to reduce labor intensity and improve the quality of technological developments for the manufacture of labor-intensive and complex parts, computer-assisted progress design automation is becoming widespread. In doing so, you can perform the following work: choose of workpiece, optimization of the road for processing the surfaces of the part, optimization of the part movement road, calculation of allowances and intermediate dimensions of the workpiece, choose of scheme for constructing machine operations, calculation of processing accuracy, calculation of cutting modes, technical standards, etc. If the operation is projected for a machine with program control, then the computer data is written directly to the machine's program carrier. The use of computer makes it possible to increase the productivity of technological and engineering calculations by 10-15 times, reduce the cost of design by 2 or 4 times, and improve the quality of design due to the optimization of design developments. Designing machine operations on a computer increases the productivity of operation by 20-30% and reduces the cost of processing parts by 10 or 15%. So we finished our lesson. have your questions. You have the questions. So our lesson is finished. Goodbye. See you next time on the next week. Goodbye.